All right, let's just wait 1 or 2 minutes before we start so that everybody has a chance to join up. All right, so we are, like I told some of you guys, we are starting off today. We are basically just going to go over really important points that are going to hopefully, I really hope, help you guys out for your upcoming exams, right? So, first of all, a little bit of an introduction. So, we are the Academy X, and the Academy itself has been around for over 10 years. One of the leading academies in UAE and in Qatar, Saudi, your entire Middle East, right? And um, okay, I think everyone's there. Right. So we are, I already mentioned, I've been teaching with the Academy for over 5 years now. And so this crash course is basically just to help out all the students with what is upcoming in your exams, right? So, yeah, by the way, we have already started taking admissions for your A levels, right? AS level, because probably, I mean, you guys don't have to worry about it yet because you have your IGCSEs going on, but A levels is generally a lot more tougher than what you do in IGCSE, right? So we have already started taking in admissions June onwards for A levels, and we do have limited seats. So if you guys are interested, please do contact the admin. The classes will be starting on in June and July. And we do have really limited seats because we only do either one-on-one or we take a batch of 3 maximum. We don't do big batches. So seats are extremely limited. So yes, let's go over what we're going to be discussing today, right? So the way we are going to be going over today is that I have basically taken all of the really important topics that you guys will see throughout your entire past papers, right? When you're solving them, you'll see these topics a lot. And these are those really big topics that if you cover, these topics will cover at least like 90% of your syllabus will be covered, right? So, but keep this in mind that this is a crash course. You will be doing it as a revision. So we don't have the time to go over everything in detail. If there's any particular topic that you guys would like to go over in detail, you guys can type it out in the chat. And if we have time, I will definitely go over it with you guys. So these are how we have divided up the schedule, right? We're going to be starting off with organic chemistry. Like, I think we can all agree it's a good chunk of chemistry, and it is, you can expect at least 1 to 2 questions in like every paper, right? Acid basis titration salts, once again, really, really, really important, right? You will see in your past papers, you'll see so many questions on it. And I will go with you guys your soluble salts, insoluble salts, how you will, what are the methods you're going to use to make it, how are you going to get the salts from the solution as well. Periodic table, extraction of metals, once again, really, really important, right? Both aluminium electrolysis and your as well as that, and of course along with that, your extraction of iron, extremely important. Electrolysis and mole calculations, once again, mole calculations is spread throughout your entire paper. Electrolysis is also one of the topics that students do find tricky. Rate of reactions, dynamic equilibrium, and chemical energetics. These topics, I do feel like I've kept them right at the end because I feel like this is something that students do generally have an idea of really well. So I've kept it right towards the very end, and then we'll finish it off with a question answer session. If you guys, meanwhile, have any questions while I'm teaching, please go ahead. Don't hesitate. Type it out in the chat. I will go over it with you guys as much as possible. Anything that you guys want me to go over in a bit of detail, let me know. If possible, I will definitely go over it with you guys. All right, so let's go ahead and start off with our first part, that is our organic chemistry. Let's take a look at that. So organic chemistry, right? We can simply go ahead and divide it into, let's say, four portions, right? So we have I've said hydrocarbons, we have alcohols, we have carboxylic acids, and we have our esters, right? So whenever you guys are studying organic chemistry, tips and tricks, okay? For every single chapter, please go ahead and list down all the chemical reactions that are under that heading. So hydrocarbons, what chemical reactions are part of hydrocarbons, right? List them down when you start studying. So you can then make sort of like a short note that this reaction, this reaction, this reaction is all related to hydrocarbon. It'll make it just a bit easier for you guys to actually learn all those reactions that are part of the topic. So, okay, once again, hydrocarbons. I'm going to go over exactly the major questions you're going to get in the exam. Everybody should know how to define hydrocarbons. It comes in the exam, right? So compounds that contain only carbon and hydrogen. That's it. It's a simple definition. It's inside the name. Compounds that contain only carbon and hydrogen are known as hydrocarbons, right? Really important. Where are hydrocarbons found? We get them from crude oil. Okay, remember that. Hydrocarbons, when we talk about them, we get them from crude oil. And specifically, if we talk about alkenes, right? So alkenes are found specifically in crude oil. Alkanes are naturally occurring. You can find them in the crude oil naturally in the environment. They have the general formula of CnH2n plus 2. Quite simply put, if you have two carbon atoms, right? So the N stands for what? N stands for number of carbon atoms. So if you have two carbon atoms, so wherever you see N, you have to substitute the number 2. So for example, if you have two carbon atoms, you have a compound that has a molecular formula of H6, right? So every compound, every homologous series has a general formula. Another really important question that you guys will see in your exam. You'll be asked to define homologous series, right? That's what they're going to ask you. What is a homologous series? What are the features of homologous series? So remember this, a homologous series has the same general formula, right? So alkanes, for example, is one series. Think of it like one group. So that has the same general formula. All of the compounds will follow the same pattern, right? It has the same general formula. Alkenes will have their own formula. Alcohols have their own formula. They all have the same general formula. Then they all have similar chemical properties. Right? They all have similar chemical properties. Number 3, they all follow a trend in their, or a pattern, you can say trend, pattern, whatever you like, in their physical properties, right? These 3 points, right? You can list them down very easily. And this is a question that you guys will see in your exam. What is a homologous series, right? So this is how you're going to define it. And we consider alkanes to be saturated hydrocarbons. Saturated simply means that they don't have any more space, right? We just can't add any more atoms in it. It's fully saturated. When asked to define in the exam, you are going to say that it is because it has single covalent bonds between the carbon atoms. So why saturated? Single covalent bonds between the carbon atoms. That's what your answer will be. And alkanes are considered to be generally non-reactive, right? Really basic stuff that we wanted to go over. Now, this point, right? Alkanes are non-reactive. Because alkanes are non-reactive, so that is sort of beneficial for you and me. How so? Well, they don't have a lot of reactions you guys have to learn. Just two. What are the two reactions you have to go over? The number one is really simple. It's combustion, right? You take your hydrocarbon, you burn it in oxygen. And when I say burn, it means you have to supply heat energy, right? And in the process, you will get carbon dioxide, you will get water, and lots of energy will be released as well. And combustion is a highly exothermic process. So, number one reaction, simple combustion. With combustion, right? Like I'm saying, the equation, my advice to you guys, learn these word equations, okay? Because the thing is that the examiners can change the hydrocarbon. They can replace methane with ethane, with propane, with butane, whatever, right? But if you learn the word equation, so no matter what reactant the examiners give you will always be able to modify your equation for your own benefit. Like you can always modify the equation. You know that the product is carbon dioxide and water. You can modify it to fit in whatever reactant the examiners have given you. With combustion equations, though, you guys want to practice what? Balancing. Okay, that's another tip for you guys. With this, please practice balancing of the combustion equations because this can prove to be slightly tricky. The second equation that we have is our free radical substitution reaction, right? So quite simply put, let me put this in really brief words, okay? What actually happens is this. If you remember, I told you guys that we have alkenes and alkenes are non-reactive. You might wonder, Miss, why are alkenes so non-reactive? The reason for that is because, like we said, they're saturated. They do not have the space to accommodate any more atoms, right? That's it. They don't have the space to accommodate any more atoms. And the covalent bond between carbon and hydrogen is quite strong as well. So it doesn't break down easily. So the only way you and I can have a chemical reaction with the alkanes, right, is if we remove one of the hydrogen and replace it with chlorine. That's it. Only way. You have to remove some hydrogen and then replace it with another atom. Hence, substitution. Okay. So alkanes give you what kind of reaction? Substitution reaction. Why? Because they are saturated. You need to remove something to add something. It's a replacement thing, right? As for the steps of the reaction, students who are doing Edexcel in Oxford, they do not to spend don't have to spend too much time worrying about the steps itself. Students who are giving their Cambridge exam, they should take some time out and just go over the steps, okay? Just the basics of the steps. So we call it free radical substitution. The reason for that is because the bond between chlorine atoms or bromine or iodine, just has to be a halogen, right? Breaks down due to ultraviolet light. Second point, you guys will get questions on what is the condition for this reaction. What's the condition? Ultraviolet light. If UV light is not available, this reaction will not happen, right? So you need UV light to actually break the bond between the chlorine or the bromine or the iodine, whatever you guys have, right? This leads to the formation of free radicals. These free radicals, what are they? They are highly reactive chemical species, right? They're just a chemical compound. Well, not a compound, a species, but they're just so reactive, right? So because they're so highly reactive, they can attack the hydrogen bond over here between carbon and hydrogen and replace it with chlorine. So they can remove this hydrogen bond, right? And instead of the hydrogen, you will end up getting a chlorine. That's it. It's that simple. Okay, you guys don't have to go into any more details other than this, right? It is this simple. Chlorine bond breaks. Condition required, you guys will say UV light. What happens? It forms free radicals. What are they? Highly reactive chemical species. What do? They attack the bond between carbon and hydrogen. They replace the hydrogen with chlorine. That's it. The final equation of the reaction is this. You guys just need to learn this overall equation. That's it. Okay. Methane correct this a bit. Sorry, this should be CH4. Methane reacts with chlorine to form methyl chloride and hydrogen chloride gas. Okay, methane reacts with chlorine to form methyl chloride is the name written, but again, you guys can call it chloromethane and hydrogen chloride gas. That's it. You learn the overall equation. We are going over all of it. Okay, that's why I'm going over specifically with you guys that this is something that Cambridge students have to go over, but Edexcel students, if they, you guys can skip it, right? That's why I'm telling you guys the difference between the two of them, because we're covering the syllabus as a general, right? So something that students of all board can go over. So for students who are doing Cambridge, they should go over these steps a bit, spend a bit of time. Students who are doing Oxford and they're doing your Edexcel, they do not have to worry about the steps, just the overall equation is good enough. All right, moving on to what's next. Alkanes is followed by alkenes. Now remember this, alkanes are not found in nature generally, right? So how can we get alkenes? We get alkenes from alkanes, okay? So we actually take our alkanes, right? And we break them down. And that's how we get the alkenes. This process is referred to as cracking. Okay. So alkenes are not naturally occurring. We can find them or we can get to them by using the process of cracking. All right. Rehan, you have raised your hand. Is there anything that you would like to ask?
Miss, what type of questions would come as like fractional distillation questions?
For fractional distillation related to this specifically, okay, fractional distillation of crude oil, you can get a question asking the principle behind fractional distillation, right? So the principle behind fractional distillation is related to boiling point, right? For example, let's take a simple example. Instead of going for crude oil, let's just take a combination of ethanol and water, right? I want to separate ethanol and water from each other. Ethanol has a lower boiling point. Water has a higher boiling point. So ethanol will evaporate and it will turn into a gas, which then I can distill off. I can use a condenser. I can collect that vapor, turn it back into ethanol, right? And collect it as a solution. Water, on the other hand, has a higher boiling point. So it will stay basically in the form of a liquid. So ethanol, since it has a lower boiling point, it will boil off earlier and I can condense the vapor and I will get ethanol and the water will stay behind because it has a higher boiling point, right? So principle of fractional distillation involves what? Differences in boiling points. The examiners can ask you for differences in boiling points. The principle of fractional distillation. So that's exactly what you will say, that in crude oil, all the alkanes have different boiling points. Based on that boiling point, they will condense in different areas of the fractionating tower. All right, so some areas of the fractionating tower are quite hot and some are quite cooler. So based on whatever their boiling point is, they will simply condense in different areas of the tower. And hence the crude oil will separate. So just like we were separating ethanol and water, now we're separating crude oil. This is fractional distillation. You will be asked of the principle behind it. And in crude oil, importantly, they can give you these fractions. Okay, so for example, crude oil can be separated into diesel, into kerosene, into naphtha. So you should know these fractions, and just like one line, of what the use of these fractions is. Yes, Rehan?
Sorry, there was an accident.
Yeah, that's it. You'll either be asked about the fractions of crude oil, right? And their uses. So just learn one line. You don't have to go into details. And the principle. That's it. That's all you'll be asked about fractional distillation. All right. So for now, coming on to our alkenes, right? Alkenes, you guys already know, have a carbon-carbon double bond. Hence, we consider them to be unsaturated. Unsaturated because they have a double bond, so we can add sort of more atoms to it, right? Now, like I said, whenever we are studying organic chemistry, what are we going to do? We are going to write down a list of every single reaction under the heading. So alkanes, two reactions, combustion and substitution. For alkenes, you guys will write down four reactions: hydrogenation, hydration, bromination, and addition polymerization, right? For every single reaction, please write down a word equation, right? I promise you, when you guys are revising, like before your exam, it'll make it so much easier for you guys, right? Word equations will help you throughout. So for hydrogenation, what happens? I'm just going to write on the grid, guys. So alkene plus hydrogen will give you an alkene, right? So for example, ethene. Ethene plus hydrogen will give us ethane. Propene. Propene plus hydrogen will give us propane, right? So you guys learn used word equations, right? So make a list of all the reactions and write on the word equation in front. So that way the examiners can give you different reactants, but you guys will know exactly what the products will be. So number one reaction is hydrogenation. For every single reaction, please also learn the conditions. Conditions being the catalyst, temperature, and pressure. So for hydrogenation, we are going to be using nickel catalyst, and the temperature is around 200 degrees centigrade. Then the second reaction is conversion of alkene into alcohol, right? And this is the good thing about organic chemistry. I don't know how interesting you find it, but if you guys ever decide to take it up into your future A levels, postgrads, grads, so you guys will actually see that in organic chemistry pretty much everything can be sort of interconverted. So I can convert an alkene into alkene and an alkene back into alkane, right? So I can convert an alkene into alcohol, but I can also convert the alcohol back into alkene. So a lot of interconversions in here. So and we can convert alkene into alcohol. Once again, what are you guys going to learn? The word equation: alkene plus, now we use generally for this we use steam, but you can also use butter, but we normally use steam. It's the same thing. Formula will remain the same, H2O. You will get what? Alcohol. So once again, you guys can now modify the equation to fit the question. Ethene will give you ethanol. Propene will give you propanol, right? The conditions are really important. Learn them. Phosphoric acid is generally what we use as a catalyst. 300 degrees centigrade, pressure is 60 atmosphere. Third reaction is bromination. In bromination, we add bromine into the alkene, right? So alkene plus halogen. It doesn't have to be bromine. It can be chlorine, can be iodine, right? Bromine, so alkene plus halogen, what is it going to give you? It's going to give you halogenoalkane. Right? So for example, you're starting with ethene. So ethene plus bromine is going to be dibromoethane, right? So you write down the name of the halogen and the name of the alkane. So it's propene, you add plus chlorine, let's say propene plus chlorine, it will become dichloropropane, right? Change the alkene into an alkane, add the halogen, whatever it is, chlorine, bromine, iodine. For this reaction, we don't need anything. It will happen at room temperature and pressure. This is also the distinguishing point between alkenes and alkanes, because alkanes cannot react with chlorine, bromine, or iodine without UV light, right? but alkenes can. Even at room temperature, pressure, nothing needed. Simply add the chlorine or bromine and they will give you the reaction, right? These guys will not. So a distinguishing feature between the two of them. And then of course we have polymerization. And now polymerization, we will go over it a bit later as well. I'll go over it with you guys properly as well. Addition polymerization is very, very important, guys. Do concentrate on it for everyone. Cambridge Edexcel, this is really important. Okay, so concentrate on addition polymerization. You should be able to draw the polymer, or if you look at the polymer, you should be able to figure out what the monomer is. Okay, it's not that hard, and if you guys learn how to do it, it will help you score marks. All right, now then we have our alcohols, carboxylic acids, and esters. Don't worry about the general formula of alcohols as such. Alcohols have a OH functional group. So because they have OH functional group, they are soluble in water, right? They have high melting and high melting boiling points, all due to the OH group that they have. Once again, for alcohols, you guys have to know which reactions are important. Number one, you guys should know about how alcohols are made. I have put a chart in front of you guys. My advice is this PPT will be available to you guys afterward the meeting anyway. But my advice is take note of this table. If you guys want, take a screenshot. This table is important. Okay. There are two ways to make alcohol. Either you can go for hydration of ethene. This reaction. Okay. The second one, alkene plus steam is equals to alcohol. This one. Okay. So either you can opt for a chemical reaction. Go inside the laboratory, take up some ethene, react it with steam, and get the alcohol that way. The second method is fermentation, right? Fermentation, you take your plants, sugarcane, for example, add yeast to it, and then you will get what? You will get your ethanol and carbon dioxide. Okay, so hydration of ethene, the chemical equation, word equation that you guys can use is that ethene plus steam is equals to ethanol. This is method number one that you guys can opt for. Learn the chemical equation for this. For the second method, once again, learn the chemical equation. It's going to be, you take your glucose. The glucose usually comes from plants. Plus, you don't need to add anything. You basically add yeast to it, and you will get ethanol plus carbon dioxide. Right? So learn the chemical equation, and more importantly, learn the differences between the two methods, right? That is really important, you guys. You'll get proper questions asking you to differentiate advantages of each method, disadvantages of each method. So like I said, if possible, go over this table. It will help you out. So one major advantage with fermentation, it's good for the environment, right? We're using plants, renewable resource, sustainable resource. Disadvantages though, it's really slow, it's time consuming, and it takes you don't get a pure form of the alcohol. The second method, hydration of ethene, environmentally not good because you still have to rely on ethene, which we get from crude oil, but it's fast, it gives you pure version of ethanol. So that's the advantage associated with it. So please go over the differences between the two of them. The second reaction related to ethanol is their oxidation reaction. Remember how I said that in organic chemistry, everything is sort of interconvertible? That's exactly what this is. So I can take an alcohol and I can convert it into carboxylic acid, right? To do that, we need an oxidizing agent. The oxidizing agent we normally use is potassium dichromate. There are two oxidizing agents in your syllabus, potassium dichromate and potassium magnate. Okay, please do go over the color changes for both of them. Potassium dichromate will go from orange to green, right? So when it's alcohol, it will be orange. And when the alcohol gets oxidized into the carboxylic acid, it will turn green. For potassium magnate, we go from purple to colorless. Then we have carboxylic acids. Once again, you should know the functional group of carboxylic acids is COOH, right? COOH, that's the functional group that we see for carboxylic acids. Now, I'm going to give you guys a hint that will really help you learn the chemical reactions of carboxylic acids. Carboxylic acids are weak acids. They act exactly like acids. So whatever chemical reactions you learn in acids and bases, the same chemical reactions apply over here. So for example, if in acids and bases you have studied that acid plus alkali gives you salt and water, you will get the same reaction. You can take this carboxylic acid, react it with any alkali, and you will get salt and water. That's the good thing about carboxylic acids, right? That their reactions is just how a normal acid reacts. So if you learn the reactions of a normal acid, carboxylic acids will give you similar reactions. And I will go over the reactions of metals with you guys in just a bit. See, exact. Now, I have put this up for you guys. I did add it over here so that if you guys want, you guys can go over all the reactions. But this is exactly how normal acids react. For example, metal plus acid gives you salt and hydrogen gas. Same reaction, nothing different whatsoever. Acid plus carbonate gives you salt, carbon dioxide gas, water, right? So, like I was saying, that these reactions are exactly the same as acid. So, for example, acid plus base gives you salt and water. So, just because it's carboxylic acid doesn't make that much of a difference. Then, the third one reaction that's really, really important that we should go over is your esterification, right? What are esters? Let's go over and discuss that. When we talk about our esters, right? So in our ester, I'm going to teach you guys a really easy way of going it. An ester is a reaction that we get between alcohol and carboxylic acid. What are the reactants? Alcohol and carboxylic acid, right? This alcohol and carboxylic acid, when they combine together, they form a compound that we call ester. Okay. Now, I'm going to teach you guys, like I said, a really easy way to go over it. Shahil, this recording is going to be given to you. It's not going to be given in the WhatsApp group because it's obviously the recording will be quite huge. But you will be given access to the recording. Okay, the link of it will be sent to you. So your for your alcohol and for your carboxylic acid, right? You can join them to make an ester. Now for the ester, right? What we are going to go ahead and do, I'm going to teach you guys, like I said, an easy method. So this is how the equation is going to be given to you guys. Even if the examiners don't give you the equation, right? They just give you the acid and the alcohol. My advice is, what are you guys going to do? Step number 1, you will draw the acid and you will draw the alcohol, right? Step number 1, you guys are going to draw the acid and you're going to draw the alcohol. Then from the acid, you will remove the OH. From the alcohol, you will remove the H. From the acid, OH. From the alcohol, remove the H. Whatever you're left with, just join it all together. Okay? So, look, what have they done? That you just join it all together. Okay? That's it. That's all you have to do. So, you are going to remove the hydrogen from the alcohol. It's gone. Remove the OH from the acid. It's gone. Whatever you're left with, just join it all together. That's it. Ester done. Right? So if if question comes in the exam, what are you guys going to do? You guys are going to draw your acid. You're going to draw your alcohol. Then remove the OH of the acid. Remove the H of the alcohol. Join it all together. There you go. All done. When you're naming the ester, first name the alcohol and then the acid. If you practice questions on these, you guys will realize that you will reach a certain point where you can literally, just by looking at the name of the reactants, right, you guys will be able to tell what the ester will be. Alcohol gets named first. So for example, if you have propanol, it becomes propyl. If you have butanol, it becomes butyl, right? So alcohol gets named first and then the acid. So if we have ethanoic acid, it becomes ethonate. If we have butanoic acid, it becomes butonate, right? First name the alcohol, then the acid. And when you're drawing the structure, draw the acid like you would normally, draw the alcohol like you would normally, remove the OH and the H, join everything together. There you go, all done. And for this, we use sulfuric acid as a catalyst. Remember that. And this reaction is known as a condensation reaction because a molecule of water is lost in the reaction. All right, last part of our organic chemistry that let's quickly go over is polymerization. Addition polymerization. I highly advise, whether you are Edexcel, whether you are Cambridge board, go over addition polymerizations really, really, really well, right? Addition polymerizations are also easier to understand. Quite simple. You have a double bond between the carbon atoms. So addition polymerization is for alkenes. Please remember that. Addition polymerization only happens in alkenes. That's it. They can't give you anything else. Okay? It needs to have a double bond for us to have addition polymerization. The double bond will open up. Now that the double bond will open up, you have space on either side to add some more atoms, right? The double bond opens up. Now we have space. I can add more atoms on either side. So the double bond will open up and more molecules will join together. Or instead of saying molecules, let's say monomer. More and more monomers will join together and you will get a large, really long chain, right? That's called a polymer. Easy way to understand this. Imagine that you are building up your Legos, right? One single block of Lego is a monomer. When you join all those Legos together, you get a huge tower, polymer, right? Same thing is happening over here. We have the double bond. The double bond is going to open right up. Once the double bond is opened up, now there's more space, right? So it will just attach itself to another monomer, another Lego piece. And then the double bond opens up and another Lego piece gets attached, right? And you end up with a whole chain. The easy good thing about addition polymers is that naming them is like so easy, right? So for example, if you have ethene, it becomes polyethene. You have propene, it becomes polypropene, right? Naming them is really easy. The name remains the same. You just add poly at the start. Then we have condensation polymerization. Now, for condensation polymerization, for Edexcel students, they should go over polyester. But for students who are doing their Cambridge, right? Please go over polyester, nylon, and also your polyamide or amino acids. Okay, Cambridge students, you guys have 3 different condensation polymers as a part of your syllabus. Okay, polyester, then you have polyamide, and you also have nylon. So please go over all 3. Okay, for students who are doing Edexcel board, this is enough. If we have time towards the end, I will go over the other 2 types of condensation polymers for any Cambridge students that we have. So quite simple, right? In polyester, we have the same thing. We have acid and alcohol. Okay, right? That's what we studied in esterification, acid and alcohol. We have the same thing. We have carboxylic acid and we have an alcohol. The only difference is that we have a compound that has 2 carboxylic acid functional groups. We have a compound that has 2 alcohol groups. That's it, right? It's the same as a normal esterification reaction. The difference comes only in the fact that there will be 2 carboxylic acids and 2 OH. Why? so that you can make a bond on either side, right? So I can make a bond on this side of the molecule, right? This side of the molecule, and I can also make a bond on this side of the molecule, right? So once again, how will you make the bond though? Very simple. Exactly like this. OH of the acid, H of the alcohol. Remove it, join everything together, right? OH from the acid, H from the alcohol. Remove this and join it all together. That's it, right? So what should you guys learn? All you guys need to learn is that we use a dioic acid. Dioic means that there are two carboxylic acids in one molecule. And we use a diol. Diol means two alcohols in one molecule. And when you join it together, you get a polyester. That's it. So, yeah, if we have time, I will try to go over the other condensation polymers also. But students who are doing Cambridge board, please go over the other types as well. That will be coming as a part of you guys will see it in your exam. So that is a really, really important stuff that we had to go over on what? On our organic chemistry. If you guys still have any questions, you guys can either list them down in the chat, right? Or you guys can send them in the WhatsApp group. And towards the end, we will go over as many questions as we can. All right, moving on from this, right? What are we going to get? Now, second, so organic chemistry, obviously important, but now we are going to move on to a topic which I think is even more important than organic chemistry. Acids, bases, titration, salts. Please, you concentrate on this topic, whether you're a chemist, whether you're Edexcel, whether you're doing Oxford, just go over this really, really well. I promise you, this is really going to be helpful when solving your past paper questions. Let me go over let me just go over like the bullets first with you guys, okay? Everybody should know how to define an acid, how to define a base. Everybody over here should know what is a strong acid, what is a strong base, what is a weak acid, and what is a weak base, okay? Then everybody should know soluble salts and insoluble salts. What salt is soluble, what salt is insoluble. Then everybody should know how we make soluble salts and then how do we get them from the solution. And how do we make insoluble salts and how do we get them from the solution, right? Another major thing, titration. Titrations related to mole calculations, really, 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 really important. We don't have time to go over all of this in detail, but I'm telling you guys all the important stuff that if you guys practice this, you will score well in your exams, right? Titrations and mole calculations, so, so, so important. Water of crystallization calculations, so important, right? So make sure you guys do go over all of this before your exam. When we talk about acids, bases, and salts, right? Let's go over it. Everybody should know how acids are defined. Acids are substances that act as proton donors. Let me simplify the definition. Any substance that donates or releases hydrogen ions. Hydrogen ion is referred to as a proton. Any substance that releases hydrogen ions is an acid. Any substance that accepts hydrogen ions is a base. That's it. Pretty simple definitions, right? Any substance that acts as a hydrogen ion donor is an acid. Any subject that accepts hydrogen ions is going to be considered a base. And every student should be able to differentiate between a strong acid and a weak acid. A strong acid is an acid that completely ionizes, completely disassociates. Let's make it simpler. Completely breaks down. Okay, I'll make it simple. It completely breaks down. It completely ionizes. You will use the term ionize in your answer. It completely breaks down, completely ionizes. A weak acid is the one that only partially breaks down, that only partially ionizes. Strong acids, let's name some. Nitric acid, sulfuric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid. There are lots of them, right? But three major: nitric acid, sulfuric acid, hydrochloric acid. Strong acids. Weak acids. All carboxylic acids are considered as weak acids, right? Similarly, you guys should be able to define strong base and weak base. Definitions are once again really similar. A strong base is the one that will completely break down to produce hydroxide ion, right? Completely breaks down. So completely ionizes to give you hydroxide ions. A weak base, once again, really simple, partially ionizes. It only partially breaks down to produce hydroxide ions. An example of a strong base. Arhan, I am not zoomed in at all. I have not zoomed in from my side at all. Maybe you have zoomed into your screen, so you might want to check that because I have not zoomed in on anything. So a strong base example, right? Group 1. Group 1, sodium hydroxide, potassium hydroxide, lithium hydroxide. They're all strong bases. Let's talk about weak bases. Ammonia. Ammonia is a very weak alkaline substance. Now, let's go on a bit further, right? Soluble salts and insoluble salts. Please, guys, this I've written for you guys. Take a screenshot, go over it if you have to, but learn it, okay? Because I promise you, it's going to help you out, right? Soluble salts and insoluble salts. All nitrates, if it has nitrate in it, it's soluble, right? That's why I always tell my students, if you guys are ever in the exam and you want to choose a soluble compound, go for a nitrate, right? Because they're always soluble. So you don't have to think. Just opt for a nitrate. All salts of potassium, sodium, ammonium. If you can't use a nitrate and you have to use something else, you have to use sulfate, chloride, then opt for potassium, sodium, ammonium because they are always also soluble, right? All chlorides, every single chloride is soluble except for three: lead, silver, mercury. Lead, silver, mercury. Lead, silver, mercury chloride does not dissolve. Lead, silver, mercury bromide does not dissolve, right? All sulfates except for lead, barium, calcium. So lead, barium, calcium sulfate will not dissolve. Anything else? Yeah, you're okay. Group 1 hydroxides. Group 1 meaning lithium, sodium, potassium hydroxide, rubidium hydroxide, cesium hydroxides. They will all dissolve. Other than that, calcium, magnesium, aluminium, iron, really low chances. So you guys will learn this. Okay. And once you guys learn this table, what are you guys going to learn? This. Okay. I know it seems like there's a lot of text on it, but I'll break it down for you guys. Don't you worry. You guys are going to start by first, whenever the examiners give you a salt, right? What are you guys going to do? You guys are going to identify what type of salt have they given me. Have they given me a soluble salt? Have they given me an insoluble salt? And this is how you guys are going to recognize soluble, insoluble. How are you going to recognize? You guys will learn this. You guys just have to learn the exceptions mostly, right? Because all chlorides are soluble except for these. Learn the exceptions, right? But this is important. I will emphasize on this. You will start by number 1, identifying what salt have the examiners given you. Is it a soluble or insoluble one? Okay. After you have chosen, so let's say you have been given a soluble salt. To make a soluble salt, there are 4 methods. These 4 methods are also the same equations that you will study for acids. Okay. This is exactly the same equations that you will study for acids and for metals. I've put everything in one place for you guys. I've made it really concise, right? I've taken the equations from the topic of metals and the equations from the topic of acids and I've put them together. So there are 4 ways, right? Simplest way. You can take an acid and simply react it with a metal. No fuss, right? Take your metal, put it in the acid. There you go. That's one way of making a soluble salt. Preferably, what are you guys going to do? you guys are always going to try to choose the reactants based on the salt. So let's take an example. Let's say the examiners have said, oh, can you please kindly make for us some, let's say, magnesium sulfate. Okay, let's say that's what the examiners have asked you. So what are you going to do? You are going to take which metal? Magnesium. So one reactant should have magnesium in it. The other reactant should have sulfate in it. So magnesium is your metal, and then you can use sulfuric acid as the acid. Okay, so remember, always choose your reactants based on the compound given. One compound should have the metal and one compound should have the negative ion. In this case, you will get salt and hydrogen gas. Like I said, learn the word equation. Because this way, the examiners can change the metal and they can change the acid as much as they want. You guys will remember that it has to be salt and hydrogen gas. You guys will have no qualms, no worries whatsoever. They'll give you magnesium and nitric acid. You'll automatically know that we have to get a salt. So salt is magnesium nitrate and hydrogen gas. They can change this up. But if you guys remember the word equation, you guys can always make a new equation yourself, right? Option number 2, go for acid, but with a metal carbonate, right? Take your acid and go for a carbonate. And please remember this, that most carbonates are insoluble. I'll add it over here, in fact, for you guys. Most carbonates are insoluble, except for 3. What are the exceptions? Except for potassium, sodium, and ammonium, right? Like over here, I mentioned to you guys that safest option always is to opt for sodium, potassium, and ammonium. So all carbonates are insoluble. These are the only exceptions. Okay, remember that. So carbonates are mostly solid, by the way. So you take your acid and react it with a carbonate. You guys will learn the word equation. What's your word equation? Carbonate plus acid will give you salt, carbon dioxide, and water. Okay, salt, carbon dioxide, water. You guys will learn the word equation, right? So if I want to make magnesium sulfate, I can take magnesium carbonate and hydrochloric acid. What will I get? I will get a salt. Salt will be magnesium sulfate and carbon dioxide and water, right? So you guys don't have to at that time stress about anything. You guys will simply remember that it's carbon dioxide and water, and the salt will be the positive and the negative ion. So in this case, magnesium sulfate will be the salt, right? Third option and super easy option, go for acid plus base, right? Really easy. Simple neutralization reaction. Take an acid, react it with an alkali. What will you get? Salt and water, right? So you can take magnesium hydroxide. You can take sulfuric acid. You can react them together, get the salt and the water. Last option, acid plus metal oxide. Now I'm going to add a point over here. Okay, what point am I going to add over here? Please remember that acid plus metal oxide is also a neutralization reaction. I'm going to say something important. Please note it down. Metal oxides are alkaline in nature. So metal oxides act like an alkali. Okay? And non-metal oxides are acidic in nature. They act like acids. So a metal oxide acts like an alkali. So wherever you have a metal oxide, it will give you the same reaction that an alkali will. Remember that. Okay? So if alkali plus acid gives you what? Salt and water. So an metal oxide plus acid will give you what? Salt and water. Okay? Wherever you have a metal oxide, everybody will remember that they act what? They act as alkalis. They'll act like alkali. So if I take a metal oxide and I react it with an acid, what will I get? Salt and water. Just like I would with sodium hydroxide, right? So step number 1, you start with identifying the type of salt. Step number 2, you choose any of these methods, whatever you like, right? These equations, though, I will advise you guys, please learn all 4 equations, okay? Like the word equations, because examiners will give you complete the equation, construct an equation, right? At that point, these word equations really help you out. So you choose one of these methods, and there you go. We have magnesium sulfate, we're good to go. Now, the second option, what if the salt happens to be insoluble? Let's take barium sulfate as our salt. Okay, barium sulfate. You guys go back to the list. You look at the list and you say, yeah, we were taught barium sulfate is insoluble. So how do we make an insoluble salt? Really easy, much easier than a soluble salt. Take any two solutions that have the positive and the negative ion and mix them. That's it. For example, you want to make barium sulfate. So take one solution of barium. So let's go for barium nitrate, right? Because nitrates are always soluble. They will always be in the form of a solution. So let's go for barium nitrate. Okay. You take a barium nitrate. Then you need something first with sulfate in it. So choose anything that has sulfate in it. Sodium sulfate, potassium sulfate, sulfuric acid, doesn't matter. Choose one solution with barium in it, choose one solution with sulfate in it. So you can go for barium nitrate, you can go for barium fluoride, right? Doesn't matter. Up to you guys, whatever you prefer. And then you will have what? You will have your sulfuric acid, potassium sulfate, sodium sulfate, doesn't matter. Take two solutions, one should have the positive and one should have the negative. That's it, mix them up together and that's it. Barium sulfate is now ready. Right? And since barium sulfate is insoluble, so you will see it in the form of a precipitate. Okay, remember this, insoluble salts give us precipitate. So go ahead and this is how you'll make an insoluble salt, right? Pretty easy. Step number one, what are you guys going to do? Identify if the salt is soluble or insoluble. If it's soluble, these are the four options you have. If it's insoluble, super simple. Just take one solution with the positive ion, one solution with the negative ion and mix it together. That's it. You guys are done. Right? Now, once the solution is ready, we have another problem, don't we? How do we get the salt out of it? Right? Once again, I'm going to help you guys out. If the salt is soluble, you guys are going to go for crystallization. If the salt is insoluble, you will go for filtration. Okay? For crystallization, let's go over important points. For crystallization, we add the solution and we heat it up slowly. Why do we heat it up slowly? Does anybody over here know why it is really important that in crystallization, we heat the solution slowly and gently? Anybody have any idea? Okay, I have one answer. Anybody else? Does anybody have another answer? Okay, to slowly evaporate the solvent. What else? Give me more ideas. All right, I've got an answer from Zainab. Viraj has given me. Ariba has also given an answer. Okay. Anybody else? Would anybody else like to add to it? Okay. So most of you are correct. The main reason is so that we don't evaporate all of the water from the solution. Right? Let me explain. We don't want to heat the solution until it becomes fully dry. That's the number one mistake you can make, right? We don't heat the solution until it's fully dry. We only heat the solution slowly so that the solution will become saturated. Let me explain this. When we are making a soluble salt, right? The examiners are going to be very specific. They're going to say, all right, how are we going to get crystals of sodium chloride? Okay. Now, what do we mean by a crystal? A crystal generally has something that we call water of crystallization. What is water of crystallization? Water of crystallization is water molecules chemically bonded with the salt. right? So they are water molecules that are chemically bonded, like they have an actual chemical bond with the salt. Okay, we call those water of crystallization. So for us to ever get crystals, okay, we need this. You don't have this, you won't get crystals, right? If you do not have water of crystallization is literally molecules of water that have a chemical bond with the salt. If you fully dry your solution, all the water is gone, we will lose the water of crystallization. And if we lose the water of crystallization, you will not get a crystal. You will get what? You will get a white powder. What's going to happen what's going to happen if we completely dry our solution, right? If you guys completely dry it, so instead of getting a hydrated, beautiful crystal, you will get anhydrous white powder, right? Why? It's the same thing. The salt is the same because you evaporated, you took away all of that water of crystallization. So you will not get a crystal. You will get what? You'll get a white powder that's anhydrous with no water whatsoever, right? So point number one, when we're doing crystallization, what are we going to do? Heat it slowly and gently until when? Number one, heat the solution in a evaporating basin or an evaporating dish gently until the solution is saturated, not fully dry, just saturated. Okay. Once the solution is saturated, then what are we going to do? Then you're going to allow it to cool down, right? Allow it to cool down. Step number three, what are we going to do then? Allow it to cool down and the crystals will form. So you heat this solution until it's saturated, not completely heated, not completely evaporation, only until it's saturated. Then you allow it to cool down. Once the solution will cool down, the crystals will be right there in front of you guys, right? What are you going to do after that? Well, you can wash and dry them. Wash them, dry them with using a paper towel, dry them using an oven, whatever you prefer, right? So this is the steps. Now the steps for crystallization are important. The reason I'm spending time on this is because this is important, okay? Please, whether you're at Edexcel or Cambridge or Oxford, you have to go over this method of crystallization, really, really important. The examiners will be asking you questions like this. Why are we not heating it until complete evaporation has happened? Or the student was performing the experiment and this is the result they got. Where do you think you went wrong, right? So you guys do need to rely on this for that. In Excel students especially, you guys will see proper 5-mark questions on this, where they'll ask you for a complete method, starting from how will you make the salt to how will you collect the salt. So highly important for you guys. Please also go over water of crystallization, okay? And especially because you guys get mole calculations on this, right? So do go over that. All right. Now, what if you have an insoluble salt? The good thing about an insoluble salt is that the method is much, much easier. You will perform simple and plain filtration, right? Filter paper kept in a funnel, and then you will slowly pour your solution. The insoluble salt is generally solid, right? So it will collect in the filter paper and solution will collect at the bottom. There you go, all done. After that, you can wash the salt, you can dry the salt. And there you go, you have some insoluble salt. Insoluble salt is easy. Soluble salts are generally harder to go for. But really important, please go ahead and spend some time learning this, okay? Also, please, water of crystallization, really important also. I mean, you have to just know the definition of this, but I'm talking about mole calculations. So do go over some practice questions on this as well. All right, then we have our titrations. With titrations, also mole calculations important, right? Titration usually done really simple. we start with taking our burette. You usually add the acid in the burette and then the alkalis in the flask, but it's not necessary. The examiners can switch it up. Okay, there's no hard and fast rule. So, okay, let me go over some important questions. Generally, we use a pipette to measure out 25 centimeter cube of acid or alkali. Like I said, no hard and fast rule. Examiners can do whatever they want. They will use a pipette. Now the examiners will ask you, why use a pipette? Why not use a measuring cylinder? Why not go for a beaker? They will ask you. You guys can go over your past paper questions. They will ask you, why are we using a pipette to measure out 25 centimeter cube of the acid or alkali? The reason for that is because a pipette is more accurate. Okay? When you use a pipette, it will fill up to exactly 25 centimeter cube. With a measuring cylinder, there's chances of error. Okay? So pipette is more accurate than measuring cylinder if you want to measure out 25 centimeter cube exactly. Then once you have taken your pipette, measured out the solution and added to the conical flask, you will add the acid in the burette. Okay. Once you've added the acid in the burette, you will open up your tap. You will slowly add the acid drop by drop. But before you start that, I'm sorry, I skipped a step. Before you start adding the acid, what are we going to add? An indicator. And this is another tip for you guys. Please, everybody learn your indicators and the colors. Okay, I want something you guys are going to do. You guys are going to learn the indicators: litmus paper, phenolphthalein, methyl red, methyl orange. You guys are going to learn these indicators and their color changes. Okay, you add your indicator and then you add from the burette drop by drop. You open the tap a tiniest bit and you add it drop by drop. Examiners will ask you why. What are you going to say? So that we can observe the exact endpoint, that exact moment. The color changes, that exact point of utilization. You guys are going to note it down, right? Really, really, really important. So this is how you'll perform a titration. Now for titration, once again, you guys get mole questions on these. Really important. Please practice your mole questions as much as you can. So all right, this is what you guys have to go over: your assets, bases, and titration. Now, I'm going to just give me 1 second. What I'm going to do is that I'm going to share with you guys another table. Please take screenshots of this table. What is this table about that I'm going to share with you guys? This is your table of chemicals, your table of chemical tests. Okay, please, 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 I'm not going over chemical test with you guys because we do not have the time, but everybody will do this. All of you guys are going to take your time and everybody is going to learn these chemical test for positive ions, chemical test for negative ions, and more importantly, flame test. Okay, please, everybody has to go over this. I'm going to share with you guys. Um, 1 second. This is a table of the indicators and their color changes, right? Important. Please, 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 you guys are going to learn this, right? If you want, go ahead, take a screenshot of this. Everybody's going to go over this. Very important. And what else are you guys going to go over? This. The test for all our positive and negative ions, right? Especially the negative ions. Even if you guys don't want to do the positive ion, it's fine. But please, everybody will learn the test for negative ions and their observations. Once again, if you guys want, go ahead and take a screenshot of this. And what else are you guys going to go over? Flame test. Everybody will learn what are the colors that each yeah, sure, I will. Just give me 1 second. this is the flame test, right? For the flame test, you guys can probably find better information or better pictures of this online, but please, everybody is going to learn the flame test as well, okay? And one final thing, everybody is going to learn the test for gases. Everybody should know the test for carbon dioxide is what? The test for carbon dioxide is that we pass it through lime water turns milky. Test for hydrogen gas is that it will, here you go, indicator slide. The test for hydrogen gas is that you put a lit match next to it and it gives a squeaky pop. Test for oxygen gas is that you place a glowing splint next to it and it will relight the glowing splint. The test for chlorine gas is that it will bleach your litmus paper. The test for ammonia gas is that it will turn red litmus paper blue. So please go over the test for gases as well. Yeah, Emma, these are the indicators that you will need to go over. Right. So going over acids, bases, and titration again, because this is highly important. In acids, bases, and titration, I want you guys to know your definition of acids and bases. Strong acid, strong base, weak acid, weak base. Everybody will know soluble, insoluble salts. How do we make them? How do we get them from the solution, right? And everybody is going to practice questions on titrations and water of crystallization, specifically mole calculations. Okay, I'm telling you guys again and again, they do give this a lot, right? So practice this as much as you guys can. Mole calculations on titrations and mole calculations of water crystallization. All right, now coming on to our third important topic that we had to go over, which was periodic table, extraction, and properties of metals. Now, in this part 3, what am I going to focus on? I'm going to focus on extraction with you guys, okay? Because I'm pretty sure periodic table and properties of metals, basic concept everybody has, right? Extraction of metals comes in past papers a lot. And I specifically want to go with you guys. Extraction of aluminum will go over, and extraction of iron I want to go over with you guys, okay? So let's go over the extraction portion. I want to go over specifically because you get really specific questions on it. Okay. Yes, Shahil, if you want, you can definitely use that. All right. So when we talk about our periodic table, I think everybody already has a concept that periodic table is consisting of periods and groups. Okay. So we have usually 8 groups and 7 periods. Now, 2 points everybody is going to remember. The group number tells you what? Okay, I want you guys to tell me. What do you think what does the group number represent and what does the period number represent? Yes, good. Yes. Good. Most of you have got it. So, period number represents how many shells there will be, right? And group number represents how many shells are in the, how many electrons are in the outermost shell. So please remember, you can use this information to help you figure out the structure of the atom. Okay, what do I mean by that? Let's say that the examiners ask you to draw the structure of let's say chlorine. Okay, when you guys are drawing it, right? You guys don't have to spend time counting the electrons and all that. I'll tell you guys a really fast way. What are you going to do? This is chlorine. Okay. And what are you going to do is you're going to see, first of all, the period number. It's in period 3. You guys are going to draw 3 shells. 1, 2, 3. Okay. Then you guys are going to look at the group number. It's in group 7. In the outermost shell, you draw 7 electrons. 1, 2, 3, 4, 5, 6, 7. That's it. You're done. In shell number 1 and in shell number 2, the number of electrons are fixed, right? Shell number 2 can have maximum of, shell number 1 can have maximum of 8 electrons. I'm so sorry, guys. Shell number 1 can have maximum of 2 electrons. And shell number 2 can have maximum of 8 electrons. That's it, all done. Right? So you can use the period number and the group number to help you solve questions really, really fast, right? Because in the exam, it's not just about being thorough, it's also about being smart. So you can use the period number and the group number to help you make these electronic configurations really, really quickly, right? Look at the outer shell, look at the period number, you draw the number of shells first, use the group number to draw the electrons in the outermost shell, and whatever you're left with, just fill it up to the maximum number. You're all done, right? And this will help you all the way up till calcium. You will not be asked to make electronic configurations after calcium. Okay, not in IGCSE. Then that's A levels. Now, when we talk about, once again, differences between metals and non-metals, really simple, really easy. I think everybody can go ahead and go over this. Metals are generally high melting points, high boiling points, shiny, malleable, ductile. Everybody should be able to explain why they're malleable and ductile. Okay. Why are they good conductors of electricity? Because they have a sea of delocalized electrons. So you guys should be able to explain these properties. Then when we talk about the reactions of group 1 and group 2. So this again is the colors of the flame test. This is a better table than the one I showed you earlier. This is a better one. So please, if you want, save this, right? You guys should know the colors of the flame test. They are, once again, like I said, really, really important. All right, I will, yeah, I'm sorry. There is a heading in typo in the heading. This is metals and this is not. You're right. There is a typo in the heading. All right. Please, like I said, learn the colors of the flame test. This is the reaction that you will see with metals. Okay. So metal plus oxygen gives you metal oxide. So lithium plus oxygen will give you lithium oxide. Sodium plus oxygen will give you sodium oxide. Potassium plus oxygen will give you potassium oxide, right? So learn the word equations. Then you can change up the reactants. You'll still know exactly what the reactant product will be. Then, once again, please learn the equation for the reaction of water. The reaction of water is quite simple. We have metal plus water gives you metal hydroxide plus hydrogen gas. Learn the word equations. Okay, so if you take a metal and you react it with water, you will get metal hydroxide and you're going to get what? You're going to get hydrogen gas. I'm going to add 1 point over here. Okay, something that I feel like a lot of students do not know. If you react the metal with water, right, the reaction is different. If you react the metal with steam, the reaction is different. This is something that students don't know, okay? If you take metal and react it with water, you get metal hydroxide, right? So sodium plus water is sodium hydroxide. But if you take the same metal and you react it with steam, right? You don't get a metal hydroxide. You get a metal oxide. Okay, so the reaction, the product is different because I know the reason I'm talking about is because students think that it's H2O, right? Water is H2O, steam is H2O. Reaction will be the same. It is metal plus steam gives you metal oxide plus hydrogen gas, not hydroxide, oxide. Okay, so remember that. And again, this is important. Why is it important? It's important because, like I said, some metals like magnesium, for example, right? They don't react with water because they're not that reactive. So don't react with water. So you'll react them with steam instead. But when they react with steam, even though chemical formula is the same, H2O, you will get an oxide, not a hydroxide. Then with group 7, what are you guys going to remember? I want everybody to remember the color that we see with group 7. Okay. I want everybody to remember the state. So chlorine is a gas, which is pale green in color. Bromine is a liquid, red-brown in color. Iodine is solid, generally black in color. I want everybody to remember that. Then I want everybody to remember that reactivity decreases down the group. Okay. What does that mean? That chlorine is more reactive, bromine is less reactive, iodine is even less reactive, and astatine is even less reactive, and so on and so forth. Displacement reactions, once again, really, really, really important. Especially for Edexcel students, you guys get proper, like you see how I've shared a table over here. You guys will get a table over here, and the examiners will ask you to fill it up with your observations and then explain it. Okay, so you have to remember that a more reactive halogen will displace a less reactive halogen. Okay, so for example, if we have a reaction between potassium bromide and chlorine, okay, so chlorine is more reactive. How do you guys know it's more reactive? Because you guys remember the point, reactivity decreases as we go down, right? Reactivity decreases as we go down the group. So chlorine is high in the group. It's more reactive. So chlorine can remove bromine. It can remove bromine and take its place, right? So it can displace, it can remove bromine and take its place. And as a result, you will get calcium chloride plus bromine. And what will you observe? You will observe that initially the solution had a blue color. It was colorless. And then suddenly it became orangish in color. Why? Because of the bromine that was produced. Okay. So please once again take a screenshot of this. You guys, it has all the observations written. Okay. So for example, see potassium iodide when you react it with chlorine. Okay. So chlorine can displace the iodine, right? Let's make the equation. I'll take the same one and I'll just move it around. Right? This chlorine can displace the iodine from the compound potassium iodide, and it can give you potassium chloride and iodine. And this iodine is going to give you a brown color in the form of a solution. Okay? So this is your displacement reaction. Now, what I really wanted to go with you guys, extraction of metals. Specifically this, the reactivity series, really, really, really important. Once again, if you guys want, please go ahead, take a screenshot of this reactivity series if you want, this table that I've added, right? The reason this is important is because it's going to help you when you're writing down your chemical equations. So for example, right, if you take a look over here, you will see that reaction. So there are 3 reactions you guys should know. Reaction with water. This was the reaction with water. Okay. Reaction with oxygen. This was the reaction with oxygen. And where did I teach you reaction with acid? In acid spaces and titration, right? This was reaction with acid. So everybody is going to remember to go over all 3 reactions. So look, potassium, sodium, calcium will react with cold water, but magnesium will not. It will react with steam, right? Zinc, iron react with steam. Now, after iron, right? You see how after iron we have hydrogen. So below hydrogen, any metal below hydrogen in the reactivity series does not react with water. This is why I said take a screenshot of this. It will be highly helpful because when you're making the equation, you know that if the examiners give you copper, no reaction will occur. Copper does not react with water. Why? Because copper is below hydrogen in the reactivity series. Okay? When we talk about reaction with our acid, okay, so potassium, sodium, calcium react violently. I promise you, if you add potassium, sodium, calcium directly in an acid, you will have an explosion in your hand, right? That's how violent, that's how reactive these guys are. Then even magnesium and aluminium give you really strong reactions. Then the reaction decreases until you get to copper, silver, gold. They again do not react. Why? Because they're lower than hydrogen in the reactivity series. Then a reaction with oxygen. Again, potassium, sodium, calcium react very easily. And as you go down, the reaction gets lesser and lesser and lesser until you get to gold, which does not react at all. Okay. Now, you guys have to know about extraction of at least two of these. What are the two important ones you guys are going to be asked about? Aluminium and iron. Okay. For aluminium, we use electrolysis. For iron, we used a blast furnace. Now the examiners will ask you. You guys will see this in your past papers. Why do we use electrolysis for aluminium? Does anybody know? What do you guys think? Why do we use electrolysis for aluminium? Why can't I use a blast furnace to get aluminium? Does anybody over here know? Okay, I've got some answers over here. Let's see. Okay. Yes. Good. I'm glad you guys have all got it, right? Because aluminum is more reactive than carbon in the reactivity series. So you cannot opt for blast furnace and you cannot opt for reduction with carbon to get the aluminium, right? So we can't get aluminium using a blast furnace. We have to opt for electrolysis. Okay, let me go one step ahead. Why can't I use electrolysis to get iron then? Okay. I mean, I can't use a blast furnace for aluminium because it's more reactive than carbon, right? Okay. But why can I not use, or why it's not cannot? Why don't we use electrolysis for iron? Does anybody know? Yes. Yes, exactly. Good job. You guys got it, right? Electrolysis is expensive. It uses a lot of energy. So if we have a cheaper option of using carbon to do it, then why would we go for electrolysis? Okay. Now, for both aluminium and electrolysis iron, you guys should know the name of the ore. Okay. For aluminium, the ore is bauxite. And the formula is Al2O3. For iron, we use hematite. Fe2O3, right? So everybody will know the chemical formulas and the name of the ores. Really, really important. Now, in extraction of iron, one question that comes in both Edexcel papers and in Cambridge papers. What question comes that not only should you guys know the process, like how does the extraction happen, but what each type of chemical equation is. Okay, so we need three things for the extraction of iron. We need iron ore, we need coke, we need limestone, right? Three things. What are the raw material? Iron ore. What is iron ore? Hematite, right? We need coke. What is coke? It's just carbon, right? And limestone. Reaction number one, this is reaction number one, everybody will learn it. Carbon reacts with oxygen to make carbon dioxide. What is the purpose of this reaction? To produce heat energy. This is an exothermic reaction. Second reaction. That carbon dioxide reacts with coke. It reacts with even more carbon to make carbon monoxide. What type of a reaction is this? Does anybody know what we can classify this reaction as? This will be classified as a reduction reaction, right? You guys see how carbon is losing oxygen, right? Loss of oxygen is reduction. So second reaction, the examiners will ask you, they will say, what type of a reaction is it? So you guys are going to say what? This is a reduction reaction. Third reaction. This is the main reaction of this process. The carbon monoxide reacts with iron oxide and gives you carbon dioxide, but most importantly, iron. That's what we want, right? We want iron. So the carbon dioxide reacts with iron oxide to give us what? The carbon dioxide reacts with iron oxide to give us iron and carbon dioxide. Okay. So this is the main reaction of this entire process of extraction of iron. And this is a redox reaction, right? Where basically your carbon monoxide is getting what? Oxidized. Iron oxide is getting what? Iron is getting reduced. So this is a, examiners will ask you, you guys will say this is a redox reaction. So carbon monoxide reacts with iron oxide to give you carbon dioxide and iron. There we go. We got our hands on the iron. Sadly, the process is not done. Okay. We are left with some problems. What are we left with? We're left with some impurities. That's the problem, right? So the problem is, like I said, that we are still left with some particular impurities to go over. So we still have our calcium carbonate or limestone that we are going to use to remove those impurities. So when we talk about our calcium carbonate, right? Our calcium carbonate, we basically need to react with silicon oxide. And when that calcium carbonate reacts with silicon oxide, it produces calcium silicate, CaSiO3. Okay. Examiners will ask you what kind of a reaction is this. What are you guys going to say? You're going to say that this is a neutralization reaction. You might be wondering, Miss, how is a neutralization reaction? Everybody will remember that we studied that metal oxides are basic in nature. So calcium oxide is basic in nature. Non-metal oxides are acidic in nature. So silicon oxide is acidic in nature. This is technically an acid-base reaction. Okay, so we get calcium silicate. Calcium silicate is known as slag. In common language, we call it slag. Okay, so the slag will collect at the bottom. We will remove the slag and the iron, and that's it, we're done. Okay, our waste gases like carbon dioxide and carbon monoxide will escape the blast furnace. So that's what you guys should know about the extraction of iron. Really important that you guys should know your equations. Chemical equations, highly important, and everybody is going to learn what each type of equation is. I forgot to tell you guys this one. The calcium carbonate. So if I'm telling you guys, let's say the chemical equations. So this is equation 3, the redox reaction. This is equation 4. The calcium carbonate breaks down to give us calcium oxide. What type is this? Thermal decomposition. And what type of equation is this? This is fifth one. So the calcium oxide will then react with the silicon oxide to give us calcium silicate. So this is a neutralization reaction. So this is how we perform our extraction of iron. So in extraction of iron, please, everybody's going to learn at least these 5 equations and then what each type of equation is. Students who are doing Cambridge board, you guys also have in your syllabus oxygen furnace, which is used to further purify the iron, right? Because this iron that we get is also filled with quite a lot of impurities. So you further purify it using an oxygen furnace. So students who are doing Cambridge board, please make sure you go over that particular thing as well. Then please go ahead and take a screenshot of this. Methods of rust prevention. Really, really important. Okay. This comes in both Cambridge board and in why isn't the second reaction redox reaction? Second reaction is classified as a reduction reaction. The reason for that is because we do see that the carbon is being reduced, but there is no oxidation happening, right? For us to see a redox reaction, there needs to be reduction and oxidation happening in the same reaction. So in this reaction, there is no oxidation, right? If you look into it, your carbon is losing oxygen, but there is nothing gaining oxygen. There is no one who is losing your there's no one that is basically gaining oxygen over here, right? You only have loss of oxygen, hence we call it reduction. For it to be redox, we need to see both the things. Yes, Shamima, if I have time towards the end, I will show you about the oxygen furnace as well. Okay. If I have time, I'll go over it. But it's probably there in your textbooks. So do go over it if you have time for your students who are doing Cambridge. Edexcel and Oxford don't have to worry about any of that. All right, this is really important. Please take a screenshot if you guys want to. I will share the PPT with you guys also. The methods of rust prevention. You guys should know the advantages and disadvantages of each method as well. And you should know about galvanizing and sacrificial protection. So do go over this if you guys have the time. Edexcel students do go over this. In Cambridge, you don't get a lot of questions on it, right? Usually in your paper two, maybe you guys will get it in MCQs, but in Excel students, you get questions on this, so please go over it. It's very important. All right. So guys, what we're going to do is that we're just going to take a small 5-minute break because I feel like everybody must be very, very saturated by now. So we're going to go ahead. We're going to take just a small 5-minute break, right? And then we're going to continue off. We're going to continue after this. Okay, so everybody, let's just take 5-minute break. You guys want to go have some water? You guys want to go get some? Yes. Yes, we will revise electrolysis. We'll do it after this. Okay. So everybody take a 5-minute break. You guys want a longer break? You guys can ask me. It's fine. Go drink some water, go walk around for a bit, eat something, and we'll resume it in 5 minutes or so. Zainab, I will teach the physics one. All right, everybody. I hope everybody is back. Is everybody here? Can I get like a thumbs up from everyone so that I know everyone's here? Everyone here? Can I get a thumbs up from everyone, please? All right, great. So if everybody is here, we are now going to move on to our next part, which is electrolysis, right? Now, electrolysis, like I said, is not, so we are going to, yeah, go over our part for electrolysis. So electrolysis, to be honest, you are not, I don't think you guys are going to find the questions that tricky related to it, right? But most definitely, it is a topic that students do find a bit trickier. So we're going to go ahead and go over our electrolysis. Okay, so in electrolysis, basic introduction, probably you guys know it. What is electrolysis? Everybody should know the definition. It comes in the exam. Electrolysis is the breakdown of an ionic compound, molten or in a solution, by the passage of an electricity through it. Learn the definition. So what are you doing? You're basically taking an ionic compound, right? And you're breaking it down. How are you breaking it down? You're using electricity. That's electrolysis, plain and simple, right? So breakdown of an ionic compound using an electricity is electrolysis. Now, for that ionic compound to be broken down, we have a requirement. What is that requirement? That the solution should either be molten or it should be aqueous, meaning that it should not be a solid, it should not be a gas. It basically needs to be in a liquid state. Either you melt it all together or you dissolve it in water, but it needs to be in a liquid state. Why? The reason for that is because, once again, in a molten state or in a solution state, whichever one, the ions are free to move. In the solid state, they're not. In solid state, they're held together by strong ionic bonds, and hence they're not free to move. So we need them to be in a molten state. Since they aren't going to be in a molten state, we can go ahead and we can perform what? We can perform electrolysis since the ions will be free to move. So they can allow the passage of electrical current to pass through. Now, as you know, we have our electrodes. The positive electrode is known as the anode. Negative electrode is known as cathode. Okay. This is for electrolysis. I just want to, clarify one concept over here. The reason I want to clarify this concept is because the Cambridge students have the fuel cell as well in their syllabus, right? Now, electrolysis, when we talk about electrolysis, so electrolysis is a part of electrochemistry. Okay. In electrochemistry, you can either use electricity to break down an ionic compound. That's what we call electrolysis. Or we can use ionic compounds or metals or other things to generate electricity. Okay. So like your batteries and cells, right? They work on a similar principle. But instead of breaking down an ionic compound, they do the opposite. They use it to make electricity. Okay. In electrolysis, we use electricity to break down the compound. So just wanted to add specifically for Cambridge students only that it's not necessary that the positive electrode will always be the anode. Okay. In a cell, it's the opposite. Okay. Now, but for electrolysis, positive electrode is the anode. I will tell you guys an easier way of always identifying anodes and cathodes. Look for oxidation and reduction. At the anode, you will always have oxidation. And at the cathode, you will always have reduction. Whether it's a cell, a battery, and electrolysis doesn't matter. Okay? Wherever you see oxidation, that's an anode. Wherever you see reduction, that's cathode. But for this topic, electrolysis, you guys can always assume that positive is anode and negative is cathode. So what happens at the positive anode? Oxidation. What happens at the negative electrode? Reduction. One thing that we're going to go ahead and we're going to talk about over here is that when we talk about electrolysis, okay? So in your syllabus, you have electrolysis of molten compound and of aqueous compounds. I'm going to teach you guys both. I will teach you how we construct half equations and how electrolysis of molten and aqueous compound is done. When we talk about our molten compounds, okay, let's start with that first. So in molten compounds, easiest thing, right? Whenever you guys get a question, the first thing you guys are going to identify, do we have molten or do we have aqueous? Okay. If you have molten, it has only two ions. That's it, the positive ion and the negative ion. So for example, we're doing electrolysis of potassium bromide. It has only two ions. It has potassium ion and it has bromide ion. Okay. Step number one, you guys will always identify, is it molten or aqueous? Once you've identified, you will write down the ions. In molten, we only have to worry about the positive and the negative ion. That's it. So we have potassium and we have bromine and that's it. We're done. Okay. Now, for potassium, right? Remember this. The positive ion goes to the cathode and the negative ion goes to the anode. What happens at the cathode? At the cathode, we get reduction. What happens at the anode? We get oxidation. That's it. This is all you need to construct your half equations. Okay. Step number one, identify molten or aqueous. Step number two, write down the ions. Step number three, identify who will go to the cathode and who will go to the anode. Positive ion goes to the cathode, negative ion goes to the anode. Potassium goes to the anode, potassium goes to the cathode, bromine goes to the anode. What happens at the cathode? Reduction. What happens at anode? Oxidation. This is all you need to make your half equations. Okay. Altaf has shared a very helpful flowchart for this. So this is very good, Altaf. Well done. You guys will, I think this will be really useful for you guys. So to make the half equation, what are we going to do? For cathode, right? What happens at the cathode? Reduction. What is reduction? Gain of electrons. So you write down potassium ion plus what does potassium do? It gets reduced, right? Because it goes to the cathode, and at cathode we see reduction. So it gains electrons. And when it gains electrons, it becomes potassium metal. So that potassium is going to collect at the bottom. For bromine, bromine goes to the anode. What happens at the anode? Oxidation. What is oxidation? Loss of electrons. So bromine will lose electrons and become bromine atom. Okay. Now, the equation for cathode is perfect. You guys can write it down as it is. Okay, the equation for cathode is perfect. Potassium gains electrons and turns into potassium metal. On the other hand, when we talk about bromine, right? So bromine is getting oxidized, right? How do you know it's getting oxidized? It goes to the anode. So bromine goes to the anode and it gets oxidized and it turns into bromine atom. Now, this over here, we need to do two small corrections. This is not the final equation. You guys need to modify it to get the final equation. One thing that you should generally do is that move the electrons to the other side of the equation. You're probably wondering, Miss, why? The reason for that is universally in the scientific community, we don't try to write down minus electrons. We always like to write down plus electrons. Okay. So generally, just like in mathematics, you would move it to the other side of the equation. So you would do the same thing over here. You could move it to the other side of the equation. Okay. So you will get bromine gives you bromine atom plus electron. Okay. The only reason we're doing it is just because this is the more acceptable way of writing it down. Okay. The second correction, and that's the more important correction, is that you have to balance it out. Because bromine does not exist as atom. Bromine exists as molecule Br2, right? So now we have to balance it out. For that, we need two bromide ions and we need two electrons. Okay. So first step you guys are always going to do, identify if it's molten or aqueous. If it's molten, you'll write down the positive ion and the negative ion. Positive goes to the cathode, so it will be reduced. Negative goes to the anode, so it will be oxidized. So for the positive ion, you will write down plus electron, okay? Positive ion will gain electron and turn into an atom. The negative ion will lose electrons and turn into an atom. For the negative equation, for the equation at the anode, you guys are going to change it further. First, you will move the electrons to the other side, right? Because that's a better, more acceptable way of writing it. You will make the electrons plus, and secondly, you'll balance it. That's it, equation is done. We are going to move this and apply this to extraction of aluminium. Okay. In extraction of aluminium, we're going to do the same thing, but this time you guys are going to help me out with it. Yes, Rehan?
Yes, overall, how many marks would that question be? The equation.
Equations generally half equations when they give you, they only come around 1 mark. That's it, right? So
Okay.
overall in the entire equation, they will overall, if the question was on this particular portion, right? So probably like the first question would be, why can we not do this with solid, or why does it have to be molten, something like that, right? And that would probably be like 1-2 marks. Then maybe they'll ask you who goes to the cathode, who goes to the anode, something like that. That would be like 1 mark. And then they'll ask the half equation. So one half equation is normally just around 1 mark. That's it.
Yes, can you show a half ionic equation?
This is your half equation, right? These
Oh,
two
that's half.
equations that we have. Yeah, these are half equations. So you can join them together to make a full equation also, but these are what half equations are. Okay. For
Okay.
yeah, for writing down a full ionic equation, that's generally not a part of your syllabus. So you guys don't have to worry about it. Full ionic equations are something you deal with in A levels. So these are both half equations. Okay, let's apply the same thing. Let's do the same thing for aluminium. Okay. Everybody's going to remember a few important points about extraction of aluminium. The ore of aluminium is called bauxite. The formula is Al2O3. Now, with aluminium oxide, when we melt it down, right? We generally add a material to it called cryolite. Does anybody over here know why cryolite is added? Why is it when I'm melting down this aluminium oxide? When I am turning the aluminium oxide into molten form, I need to add cryolite to it. Does anybody know why? Okay, I'm getting some answers. Anybody else? Would anybody else like to contribute? All right, Anusha, you have got the right idea. Okay, it is generally used to yes, to lower the melting point, or in the exam though, they normally prefer using operating temperature. Okay, but it's basically to lower the operating temperature or the working temperature of aluminum oxide, because aluminum oxide has like a really, really high melting point, right? Like it's all the way up to, you can say, like 2000 degrees centigrade, something like that. So it's like going to be like really, really, really costly. I mean, how are we going to melt it? Right? We're going to melt it using fossil fuels. You guys can imagine the amount of fossil fuel you would need to use. Yes, this is also Edexcel related. And the questions that I'm specifying do come again and again in their Excel paper. So when you talk about it, so cryolite is added to it to lower the working temperature, because aluminum oxide has a very high working temperature. So yes, you do need to know. You need to know in your example of electrolysis, especially about aluminum, you'll see a lot of questions. And then in aqueous form as well, related to sodium chloride, you'll see a lot of questions. And this is something, by the way, important for Cambridge and Edexcel students. Okay. So when we talk about our so you guys will get a question, right? Number 1 point, everybody remembers the name of the ore. Number 2 point, everybody remembers why cryolite is added. Okay. Then there's third important point that I want to mention. But before we mention that, let's go over our process first. So this is molten, right? Everybody's going to remember that in molten, we write down the positive ion and the negative ion. Our compound is aluminum oxide. So that will give us the positive ion, aluminium, negative ion, oxide. Okay. Positive ion goes where? To the cathode. Negative ion goes where? To the anode. What happens at the cathode? Reduction. What happens at the anode? Oxidation. And then you guys will use this to make your half equations. You guys, okay, if you want, you can learn the half equations, because the electrolysis that you see in front of you, right, for aluminium, for sodium chloride, these generally, this is all you will get in your syllabus. Students who are doing Cambridge board, they might get sulfuric acid and all as well, right? But this is generally it. So if you guys want to just learn it, you guys find it difficult to understand, and the exam is right on your head. For Cambridge students, the exam is Wednesday. So if the exam is literally on your head and you don't have the time to understand it, you guys can just learn it. But I'm going over the concept behind it, because I want you guys to be able to make the half equation, just in case the examiners give you something different, right? If they give you something that is not normally like not one of these examples that I'm going over with you, right? They take something out and they give it to you something new. So I'm going over the concept. I'm teaching you guys how to make the equations, just in case they give you something on the side and they ask you to make an equation, you guys will know exactly how to make it. Okay. But if you don't have the time, let's say, you guys, like, you don't have the time to go over this right now. If you don't have the time, please just learn, at least for the examples that I'm going over with you guys, learn the half equations, learn the important points I'm telling you. So at least if it comes in the exam, you guys can give answers like this. Okay. At least these examples, just learn them. And this is for also Edexcel students, not just for Cambridge. Comes in both papers and very important. Okay, so now aluminium is going to get reduced. So what is reduction? Reduction is gain of electrons. So aluminium will gain electrons. How many electrons? 3. How do you know 3? How do you know it's 3? Because the charge of aluminium is 3 plus. That's how you know. Aluminium is in group 3. Its charge will be 3 plus. So it will gain how many electrons? 3 electrons. And turn into aluminium. All done. For oxygen, how do we write it down? Well, for oxygen, we have to do a few steps. First of all, oxygen is going to get oxidized. So it will lose electrons. How many electrons? 2 electrons. How do you know? Because the charge of oxygen is 2 minus. It will lose 2 electrons and turn into oxygen atom. Step number 2. Let's move the electrons to the other side. Okay, let's move the electrons to the other side. Why are we doing that? Just because that's a more acceptable way of writing. Step number 3, and this is important, balance it out. Oxygen is never O. Oxygen is O2. So that means we will need 2 negative ions. And how many electrons will we need? We will need 2 2s are 4 electrons. So this will be the final equation. Again, if you guys are finding it tricky to actually figure out how to make the equation yourself, learn them, okay? At least learn them. So in the exam, you guys will be okay. But this is what we do. What do we do? First, we write down the oxidation. So we're simply going to write down that oxygen loses electrons and turns into oxygen atom. Then move the electrons to the other side and simply balance it out, right? So the half equations, we are all going to remember. The third question that you guys are going to see again and again and again and again in your past papers, pretty much every time you deal with extraction of aluminium, and that is this. Please remember what is produced at the anode, oxygen, right? What is produced at the cathode, aluminium metal. What is produced at the anode, oxygen gas. But we have a problem. What's the problem? And the problem is this, that this oxygen gas reacts with the carbon anodes. Please remember this, okay? Carbon anodes are generally non-reactive, but in this case, they're not. These carbon anodes react with the oxygen and form carbon dioxide gas. This is why the anodes have to be replaced frequently. This is specifically for aluminium, not for anything else. Only for aluminium. And you guys will see this in your past papers. That why do we need to replace the anodes again and again? Why do we need to replace the anodes frequently? Because what is produced at the anode? Oxygen. That oxygen will what? It will react with the carbon and what will it do? Produce carbon dioxide. As a result, the anode gets used up. The anode is taking part in the reaction. It gets used up. So we need to replace it frequently, right? So you guys will remember what about aluminium? You guys will remember the name of the ore. You guys will remember why we use cryolite. You guys will remember why the anodes have to be replaced. You will remember why do we need to use electrolysis? Because aluminium is more reactive than carbon. You will remember the half equation for cathode and anode, right? You will learn these points so that all questions of aluminium will be super easy for you guys. This was for molten compounds. Now let's go on to aqueous compounds, right? What are aqueous compounds? Aqueous compounds are compounds that are dissolved in water. Okay. Now, why are we studying this separately? We are studying this separately is because whenever I dissolve anything in water, I then have to also worry about the water ions. Okay, let's take an example. This is, let's say we are doing electrolysis of sulfuric acid. H2SO4. What are you guys going to do? Identify, is it molten or aqueous? The examiner said it's aqueous. Step number 2, write down the ions. What ions do we have? We have hydrogen ion and sulfate ion. We can see that in the equation. We can see that in the compound. But we also have hydrogen ions from the water and hydroxide ions from the water. This is where the problem comes, right? In molten, it's pretty simple. There's just the ions from aluminium or oxygen. That's it, right? If you're doing potassium bromide, it's potassium and bromine, 2 ions, super easy. Positive goes to the cathode, negative goes to the anode, done. In aqueous solutions, we have 4 ions, right? We have hydrogen ion from the water and hydroxide ion from the water as well. And then we have the ions from the compound. So from sulfuric acid, total of 4. Now, again, it is really easy to identify who will go to the cathode, right? Because in positive ions, we don't have a lot of option. We just have hydrogen. I mean, that's it. Whether it's water, whether it's the acid, they're both just giving us hydrogen ions. Super easy. So who goes to the cathode? Hydrogen. And what happens at the cathode? Reduction. The question comes between sulfate ion and hydroxide ion. Now we have 2 different negative ions. which one of them is going to go towards the anode? For that, we have something known as the electrochemical series. Okay. The electrochemical series, the lower we go, the easier, the more chances that it will go to the electrode. Okay, the lower any particular ion is, the greater the chances that it will go to the electrode. So for example, in this question, we don't have to worry about it. We just have hydrogen. But let's say we had sodium and we had hydrogen. So between sodium and hydrogen, who will go to the cathode? Sorry, guys. Who will go to the cathode? Hydrogen. Why? Because hydrogen is lower. Okay. Between zinc and hydrogen, who will go to the cathode? Hydrogen. But between hydrogen and copper, who will go? Copper, right? So this is something you guys it's really easy concept though. Basically, the lower it is, the greater the chances that it will go to the cathode or the anode, doesn't matter. Okay, so if you have, let's say, two ions, zinc and hydrogen, hydrogen will go to the cathode. But if you have hydrogen and copper, then copper will go to the cathode. Okay, same is with the anions. So we have two ions, sulfate and hydroxide. So hydroxide is the lowest. So hydroxide is the one that will go to the anode. Okay, so who will go to the anode? Hydroxide. Now for the hydroxide ion, I'm telling you guys the half equation. Just learn it, okay? Because this is slightly complicated. My advice is learn the half equation for hydroxide. Wherever the examiners give it to you, just write it down as it is. Okay? So what is going to happen at the cathode? Let's see. At the cathode, we will get reduction. The hydrogen ions will gain electrons and turn into hydrogen gas. On the anode, the who will go? The hydroxide ion. Why? Because it's lower in the electrochemical series. So the hydroxide ion will go and it gives you water and oxygen. For this equation, please just learn it, okay? All right, just learn the equation for hydroxide ions. 4 hydroxide ions give you 2 water, 1 oxygen, and 4 electrons. Okay, so this is how you will solve questions for aqueous solutions. Perfect. All right, now I'm sorry, this is going to get slightly more complicated because so far the students, they still managed to figure it out, right? It seems simple that we are going to choose whichever one is lower in the series, and that will go to the cathode and the anode, and we make the half equations. But sadly, it gets further slightly more complicated. How does it get complicated? Because sometimes the examiners ask you about concentrated solutions. Okay, this is where it gets complicated. The examiners say, what if we make the solution concentrated? Now, remember this. If the examiners say dilute, this is what you will do. What I just taught you right now, this is what you will do. Dilute. This is what you will do. Okay, choose whoever is lower in the series. That's it. That's the one going to the cathode. That's the one going to the anode. But what if you make it concentrated? If you make it concentrated, now we're going to go over it slightly different. Okay, let me just cover that. So again, if we have concentrated sodium chloride, what are we going to do? Positive ion is sodium, right? Sodium chloride has sodium and chloride ion. Now this is aqueous, right? So we also have to consider the hydrogen ion and the hydroxide. Now, let's talk about the cathode first. At the cathode, we have sodium ion and hydrogen ion, 2 options for the cathode. Either sodium ions can go to the cathode or hydrogen ions. Now, looking at the electrochemical series, I want you guys to tell me. Go ahead, I want predictions. What do you guys think? Between the sodium and the hydrogen, because these are the 2 options, right? Sodium from the NaCl and hydrogen from the water. These are the 2 positive ions. Which one should go to the cathode? What do you guys think? Okay, I've got some answers. Let's see. Okay, people who are saying hydrogen are correct. Which one do we choose? The one who is lower in the series. Which one will you pick? Lower one. Okay, whichever one is lower in the series, that is the one that will go. Okay, remember this, whichever one is lower. So we have two options, either sodium, right? Either sodium or hydrogen. We have two options. Whichever one is lower in the series, that is the one that will go. Okay, so who is lower in the series? Hydrogen. So who will go to the cathode? Hydrogen. Okay, pretty simple. So who do we pick? We pick hydrogen. Now, we have the option between chlorine and hydroxide. Now, over here, I'm going to write down a point. You guys are going to pay attention to whether the examiners have asked you if the solution is dilute or if it's concentrated. Okay? If it's dilute sodium chloride, who will go to the anode? Hydroxide ions. Why? Why are the hydroxide ions going to go to the anode? Because they are lower. Remember, the lower one goes. Whichever one is lower, that one will go. So in our reactivity series, right? Whichever one is lower, that is the one that will go. So if it's a dilute solution, who is going to go? Hydroxide. But if it's a concentrated solution, who will go to the cathode? Chlorine. Why? And the examiners will ask you, especially Cambridge students. You get a lot of Edexcel, you also get questions on this. But Cambridge students, your questions focus on this a lot. Okay, they will ask you that, they will specifically give you dilute and concentrated, and then they will say what are the products going to be. In dilute, you get hydroxide ion. This is the equation. Oops, sorry. This is the equation. Okay, the hydroxide ions will go, oxygen will be produced. Okay, but in concentrated, chlorine goes to the electrode, and the examiners will ask you why. And what are you guys going to say? You guys are going to say because the concentration of chlorine ions is very high, because this is concentrated sodium chloride. Since this is concentrated sodium chloride, so the concentration is what? The concentration is very high. The concentration of chloride ion is so high that it, even though there's a difference, right? You guys can see there's a difference between the two ions, but the concentration is so high that it will be the one that will end up going to the electrode. Okay, so you guys need to go ahead and remember this. Especially, I'm emphasizing for the students who are doing Cambridge board, right? You make sure you guys learn this. For dilute sodium chloride, we get hydrogen gas and oxygen gas. Why oxygen gas? Because hydroxide ions will go to the anode. Why hydroxide ions? Because they're lower in the reactivity. Okay, they're easier to discharge. On the other hand, if it's concentrated, then hydrogen and chlorine gas. Dilute, hydrogen and oxygen. Not dilute, concentrated, then hydrogen and chlorine. Why chlorine? The reason we get chlorine is because chlorine is just that high in terms of concentration. Okay, so this is what you guys should go ahead and you guys should know about. So my overall take from electrolysis that I want to tell you guys, everybody should know extraction of aluminium, especially the points I went over. Make sure you guys know this really well. Then everybody should know, especially about sodium chloride. Students who are doing Edexcel, they can just learn about concentrated sodium chloride, and that's usually, I think that's enough. Students who are doing Cambridge board, you guys should know specifically about dilute and concentrated. Okay, because you will be asked about questions related to both of them. Both of you guys, both boards should know very well how to construct half equations. If you guys find it difficult to make the half equations yourself, at least learn the half equations for potassium bromide or lead bromide, okay, aluminium and sodium chloride. At least for these three, learn the half equations. All right. These you guys should know really, really well. All right. Then coming on to mole calculations. For the mole calculations, we don't have a lot of time to go over any of the calculations or portion of it, obviously. So I have just gone ahead and listed the formulas that you guys are going to end up needing to use. Okay. One formula that you guys are going to find yourself using is this one, which is N is equals to M over MR. Okay. This is a formula that is used specifically related to solids, but you guys can use it for liquids and gases if needed as well. The formula is quite simple. N stands for moles. M stands for mass in grams. Important. It's in grams. Please remember this. Okay, not in kilograms. If the examiners give you kilograms, convert it into grams. And what is MR? MR is the molecular mass. Calculating molecular mass is super simple. Okay. For example, you have sodium chloride. So what are you guys going to do? Open up your periodic table. Take the mass number of sodium. So mass number of sodium is 23. Take the mass number of chlorine, that's 35. And simply add them up, right? That's how you calculate the molecular mass. So if you take the mass and divide it by the molecular mass, you can get the number of moles. Then the second formula I'm going over is used specifically for liquids. Okay. The formula is concentration is equals to moles over volume. This is for liquids. Okay. Everybody is going to remember that concentration is in mole per dm cube. Okay. Everybody is going to remember that volume has to be in dm cube. Please remember that majority of the questions, not in every question, but in most of the questions, you will have to do conversions. Okay. They will give you probably centimeter cube and you will have to convert it into dm cube. So everybody will remember when we are doing mole calculations, what are we going to concentrate on? One of the things we're going to look at is always the unit. Okay. Everybody's going to pay attention to the unit. When you read the question, try to underline the values so you guys can see what the unit is. Okay. So concentration is in mole per dm cube. Volume has to be in dm cube, right? If the volume is in centimeter cube, please convert it into dm cube before you do any calculations. Okay. Third formula is related to gases. Okay. The formula related to gas is N is equals to V over 24 dm cube. So N is the moles of the gas. V is the volume of the gas, right? And then you divide it by a number known as 24 dm cube. What is this number? I don't know if you guys know what it is or not. This is scientists measured that if we have 1 mole of a gas, what will the volume be? They measured it out. This is something that they calculated. That what is the volume of a gas, 1 mole of gas, 1 mole. So they got the value 24. Okay, that's how they came up with the formula. And this is the value at room temperature and pressure. Okay. Meaning that if you change the pressure, if you change the temperature, the value can change, but you guys don't have to worry about that. Okay. For you guys, if it's a gas, the formula you will use is N is equals to volume divided by 24 dm. If we have time towards the very end, I might go over a few more questions with you guys. Now, coming on to our last portion, which is our rates of reactions, dynamic equilibrium, and finally, we of course have our chemical energetics. In this, I want to focus with you guys on dynamic equilibrium because even for students who are doing Cambridge Board and Edexcel, you get a lot of questions on this. Okay. And if you guys look at the recent papers, especially the Cambridge students, if you guys look at the recent paper, right? So they're giving you proper tables where they're asking you what the effect is going to be of the pressure, temperature, all of that. That usually is like around at least 4 marks. So important that we have to go over this. So when we talk about rate of reaction, everybody should know about the factors affecting the rate of reaction. This poster in front of you guys is pretty much a summary of everything you guys need to know. Okay? So everybody, we basically have to know what the effect of the factors affecting the rate of reaction. So concentration is one factor, temperature, surface area, pressure, and catalyst. If you increase the concentration, the rate of reaction will increase, right? Okay, the examiners will ask you to explain why. For this, you guys have to give a very specific answer talking about the collisions. And you guys will get marks if you include the collisions in your answer. So if you increase the concentration, what will happen? The number of particles will increase. Greater the number of particles, greater the number of collisions. Greater the number of collisions, the more successful collisions there will be. So the rate of reaction will be higher. You guys need to mention this point in every single answer. Otherwise, you guys will lose marks. Greater the concentration, greater the number of particles. Greater the number of particles, greater the number of collisions. Greater the number of collisions, greater the number of successful collisions. Hence, rate of reaction is higher. That will score you full marks. Then temperature. When you increase the temperature, the rate of reaction increases. I want you guys to tell me why. Why is it that when you increase the temperature, the rate of reaction increases? There are two separate points that I'm looking for. Let's see if you guys can figure out what both the points are.
Miss, could you repeat?
Yes, I will repeat. When you talk about increase in rate of reaction related to temperature, right? So when you increase the temperature, the rate of reaction also increases. I want you to give me the reasoning as to why. Why is it when I increase the temperature, the rate of reaction also increases? There are 2 points that I'm looking for. So you have to give me both of those points. Yes, Shamima has got both of the points. Okay. I'm going to do one thing. I'm going to type out the answer in the chat. Okay. So everybody, if you guys want to note it down, you can note it down. Okay. But basically what happens when you increase the temperature, the rate of reaction increases. Now there are 2 points. Okay. Point number one. This is due to increase in number, this is due to increase in kinetic energy of the molecules or the particles. This increases the frequency of collisions because they have more kinetic energy, so they'll move faster, right? So this increases the frequency of the collisions and increases the successful collisions. This is point number one. Okay, so point number one is related to what? It's related to kinetic energy. Greater the temperature, higher the kinetic energy of the molecules. The greater the kinetic energy of the molecules, the faster they will move. The faster they are going to move, the greater the number of successful collisions, and hence your reaction will be faster. The second point, which you guys, this is something that I've noticed most students do not know. Okay, the second point is that increasing the temperature, it doesn't just increase the kinetic energy. It increasing the temperature also increases the proportion or the fraction of molecules that have the activation energy. So not only does it increase the kinetic energy, it also increases the number of molecules that have activation energy. It doesn't change the activation energy. Remember that. Activation energy does not change. It remains the same. But it increases the number of molecules that have that activation energy, right? So more successful collisions, and hence the rate of reaction is higher. So there are 2 points, 2 reasons, okay? So you guys should learn both the reasons. Number 1 is due to increase in kinetic energy. Number 1 is due to increase in molecules that have that activation energy. Okay, so include both the points when you're giving your answer. I've typed it out in the chat if you guys just want to note it down. Okay, next, increase in surface area. Please go ahead. What do you guys think? When you increase the surface area, the rate of reaction increases. Can you guys explain why it increases? Yes, okay. Ataf has given an idea. Mm-hmm. Mm-hmm. All right. Yes, you are right, basically. So if you increase the surface area, there are more particles that are exposed. Okay. So the number of particles exposed are greater. Okay. Hence more collisions, hence more successful collisions. So rate of reaction increases. Right? Perfect. Then pressure. As you increase the pressure, the rate of reaction increases. But for pressure, I want to mention one point. Please remember, pressure will only affect the rate of reaction if it's a gas. If your reactants are solids and liquids, nothing will happen. Okay? Pressure will only affect the rate of reaction if it's a gas. And catalyst. We already know the function of a catalyst. A catalyst lowers the activation energy, so it makes the reaction go faster. Okay? Now, this is the graph. Everybody should know how to draw the graph of rate of reaction. Students who are doing Edexcel board, they know that specifically they get a lot of questions related to this. Sometimes the examiners will give you a table and ask you to plot the graph as well. So you can find the rate of reaction by finding the gradient of the graph. Okay, if you guys are ever given the exam questions and you're asked to find the rate of reaction, there are 2 ways actually you can go for it. Number 1 way is that you can just take the values from the x-axis and the y-axis and divide them. Okay. The second method and the better method is that you use the gradient of a tangent. A tangent is a line that we use to find the gradient of a curve. Okay, because for a straight line, it's really easy to measure the gradient, right? But for a curve, not that easy. So we actually draw a tangent. A tangent is a line that touches the curve at one point only, or as close as you can get it, right? So you will simply draw a straight line that touches the curve at one point only and then calculate the gradient. Okay. Or you guys can simply choose the value from the x-axis and the y-axis and divide the 2 of them. Okay. Again, these graphs, please, if you guys want, take screenshots of these. You'll get the PPT, so if you guys don't want to, it's fine. But these graphs, the examiners will ask you to draw. Remember this, that as you, for temperature, for pressure, for catalyst, for surface area, okay? This is the graph. If the examiners ask you to make a graph of the temperature, increasing the surface area, you're increasing the pressure, adding a catalyst, whatever. This is the graph you will make. Okay. So you guys can see that at a higher temperature or higher surface area or higher pressure, the rate of reaction is increasing, right? The line is becoming steeper. The gradient of the line is increasing, right? But the final product is the same. The amount of the product you're getting does not change. The rate of reaction increases. Yes, the reaction becomes faster. You will get that same volume in the less amount of time, but the total amount will be the same. But if you change the concentration, this is the graph you guys will look at. Okay. If you increase the concentration, so the rate of reaction will increase. Yes. But the amount of amount of product will also increase. Okay. So with temperature, surface area, and pressure, the reaction gets faster. Yes, you will draw a faster reaction. Steeper gradient, steeper line, but the final product is the same. For concentration, though, remember this, if you double the concentration, the amount of product will double. The reaction will also increase. Yes, the speed will increase, but the final product will also increase. If you decrease the concentration, the final product decreases. So when you are asked to make a graph of concentration, you guys will remember not only to increase the rate of the reaction, but also to change the amount of product. But for temperature, surface area, pressure, it will not change, only the rate of reaction will change. Now, before we do chemical energetics, I want to do this, right? I want to go over dynamic equilibrium with you guys first. For dynamic equilibrium, please, I want you guys to note this down, okay? When you talk about dynamic equilibrium, so first thing first that the examiners are often going to ask you is what is dynamic equilibrium? What are the features of dynamic equilibrium? Can you guys please list them down for me? What are the features of dynamic equilibrium? There are generally around at least 3 features that you guys can give of dynamic equilibrium. Let's see if you guys can get all 3. That was awesome. Perfect. I've got some really good answers over here. I'm going to go ahead and list out all the points in one message. So if anybody wants, they can just go ahead and note them down. Number 1 point. The forward reaction and backward reaction happen simultaneously, okay, or at the same time. Occur at the same time. That's point number 1. Okay. Point number 2 is that the rate of forward reaction is equals to rate of backward reaction. Point number 3 is that the concentration of the product and the reactant is constant at equilibrium. And there's one point that we're going to add to it. right? What's that fourth point? That this happens in a closed system. It has to be a closed system. What do we mean by closed system? Closed system means that none of the reactants and the products can enter or leave that particular area. So if you're doing it in a flask, for example, none of the products and the reactants can enter or leave. This is a closed system. If you do not have a closed system, dynamic equilibrium will not get established. Okay. So for dynamic equilibrium to get established, this has to happen in a closed system. Okay. Now, let's look at our three factors: concentration, temperature, and pressure. For a concentration, what are we going to see? That simply, if you increase the concentration of the reactant, so the reaction will shift to the, you guys can note this down if you want, okay? If you increase the concentration of the reactant, the reaction will shift to the right-hand side. So the amount of product will increase, right? Makes sense. Add more reactant, get more product. If you increase the concentration of the product, the reaction will shift to the left-hand side and the amount of reactant will increase. Okay. Add reactant, get more product. Add product, get more reactant. Okay. If you add reactant, it shifts towards the right-hand side. Add the product, it shifts towards the left-hand side. Now let's come on to temperature. Okay. So in temperature, what are you guys going to see? That when you increase the temperature, it will shift the endothermic, it will shift the equilibrium to the endothermic side. And if you decrease the temperature, it will shift it to the exothermic side. If you increase the temperature, it will go to the endothermic side, whichever side absorbs the heat. If you decrease the temperature, it will shift to the exothermic side, whichever side produces the heat. Let's take an example. What example are we going to take? I'm going to take the example of Haber process, making of ammonia, with you guys. Okay. So for making of ammonia, this is our equation. Okay. Now, this is generally an exothermic process. How will you guys know it's an exothermic process? The value of delta H will be given to you guys by the examiners. Okay. So please remember this. That forward reaction is exothermic with whatever the examiners have given you. If they've given you a negative value, that means that the forward reaction is exothermic. If the examiners give you a positive value, that means that the forward reaction is endothermic. The value given to you is always for the forward reaction. Remember that. Whatever enthalpy change delta H the examiners have given you, that's always for the forward reaction. So the forward reaction is exothermic. Okay. That means the backward reaction will always be opposite to it. The backward reaction will always be endothermic. Okay, they're always opposite to each other. So if the examiners have given you delta H positive, that means forward reaction is endothermic. And then the backward is exo. If the examiners have given you delta H negative, what does that mean? Backwards is endo and forwards is exo. Okay, whatever the delta H value is, that is for the forward. And the backward reaction will be opposite to it. If you increase the temperature, it will go to the exothermic side. Sorry, endothermic side. Endothermic. Endo. So that means if I increase the temperature, the reaction will go towards the left-hand side. And the amount of ammonia will decrease. This is exactly the kind of questions they're going to ask you, okay, in your exam, like both Cambridge Edexcel. They'll literally give it to you like this, that they'll give you an equation and they'll say we're increasing the temperature. What will happen to the amount of ammonia? This is very important. If you decrease the temperature, it will shift towards the exothermic side, which is the right side, right? Exothermic side is the right side. So it will shift to the right side and the amount of ammonia will increase. Then pressure. When you increase the pressure, the equation shifts to the side with less number of molecules. This number of molecules is really easy to figure out. Okay. On the left hand side, we have 3 and 1, right? So we have 4. On the right hand side, we have 2. So if you increase the pressure, the equilibrium shifts to the side with less number of molecules. Which side has less number of molecules? Right side. So it will shift to the right. And the amount of ammonia will increase. If you decrease the pressure, the equilibrium shifts to the side with more molecules. So which side has more molecules? Right, left hand side. So it will shift to the left hand side. And what will we get? We will get less. So you guys should be able to look at any equation and figure out how the equation will shift depending upon adding changing temperature, pressure, and concentration. The last thing is catalyst. Please remember, catalyst has no effect on equilibrium. I'm not talking about rate of reaction. It has no effect on equilibrium. The examiners will ask you, they will say, why does it have no effect on the equilibrium? You are going to say, because it increases the rate of forward reaction and backward reaction equally. So it has no effect on just one side. It will increase both forward and backward, and it will do it equally. Okay. Now, students who are doing Cambridge board, please go over Haber process and please also go over your contact process. Okay. For Haber process, the examiners, you guys need to learn the catalyst, the temperature, and the pressure. Now, you guys will get questions like this, right? So one thing that you guys will see in recent papers is that they've started giving you tables and asking you to complete the table, right? Showing the effect of increasing temperature, decreasing temperature, all of that. Now, on Haber process, the examiners do give you specific questions, and these questions sometimes come in relation to Edexcel students as well. Okay, so for Haber process, sometimes they'll say, for example, right? So you guys can see that if you decrease the temperature, the amount of ammonia increases. So the examiners will first say that what happens when you decrease the temperature. So you guys will say, all right, when we decrease the temperature, the reaction shifts to the exothermic side, the amount of ammonia increases. Okay. Then the examiners will say you, okay, then why don't we perform the reaction at a low temperature? Why is this reaction done generally around 400 degrees centigrade? 400 to 450. Why? Why not do it at 20 degrees centigrade? Because you clearly right now, you're just saying to me that if we lower the temperature, the amount of ammonia should increase. So why don't we do it at a low temperature? And that's when you guys are going to answer that because at a low temperature, the rate of reaction is so slow that the ammonia we get will be produced very, very slowly. Okay, I'm literally giving you guys exam questions right now. So what will you guys say? That if you decrease the temperature, the amount of ammonia increases. Yes, the equilibrium shifts towards the right hand side. But the speed at which you will get that ammonia is going to be like low, so less, right? Because the rate of reaction drops down significantly. All right, the examiners will say, perfect, makes sense. Now, you just said that if we increase the pressure, the amount of ammonia increases. So why don't we do this at a very high pressure, right? That's when you guys are going to say, because doing it at a very high pressure is costly. It is expensive. Producing that high of a pressure is not that easy, right? So this is the kind of questions you guys can expect. And for this dynamic equilibrium, you guys just need to practice how the equilibrium will shift and if the amount of product increases or decreases. For you're getting easily in recent papers, you're getting a lot of questions on this. So you can easily score good 4 or 5 marks if you answer this correctly. All right. So does anybody have, let's do, we have 5 minutes left. So let's go over any questions. If anybody has any questions, please guys, go ahead, ask me any questions and I'll try to answer it out as best as I can. I think if you guys can type it out in the chat, then I can go through them one by one. Whatever questions you guys have, any confusions. Yes, Rehan, go on.
Miss, I've checked like the recent
Mm-hmm.
papers that I've had. So for January 2025 and
Mm-hmm.
for 2024,
Mm-hmm.
both the years the papers aren't showing like that. Only one of the paper had empirical formulas. So are they gonna get less common as well?
Yeah, basically what you're seeing in the recent paper is that the trend has changed a bit, right? So, yeah, I think that's what you can expect. But do keep in mind that the January papers are generally slightly different than the ones you give in May, June also. So my advice would be to
Yeah, I
look at the May,
checked.
June paper.
So the last empirical formula that they had in 2024 was not June but January as well.
Yeah, exactly. So the chances are less. But the thing with the examiners is that once again, so you will notice that the recent papers tend to have a bit of a trend, right? But then all of a sudden they can change and they can start giving something different. So that's what you can expect. But on the safe side, I would advise you, if you do have the time, then please go ahead and go over the empirical formula portion as well.
Just like, is there I have another question? Are you gonna send us a formula sheet for the all
Yeah,
the
yeah, go
needed
on.
formulas? Are you gonna give us a formula sheet?
I'm sorry, Han, your voice is getting cut, broken. I could not hear you properly.
Miss, what I was saying was, are you gonna give us a formula sheet for revision?
All right. I will. Okay. I'll do it a bit later. I'll send it in the group. Okay. I'll share a formula sheet with you guys to make it easier for you guys to go over it. Ali, at this time you should go over notes. Okay, this is not the time to be going over textbooks. Go over notes and practice as many past papers as you can. Okay, just a reminder for everybody over here. Students who are done with theory, okay, like they know their theory. At this point, concentrate on past papers, as many past papers as you can. Students who are doing Cambridge, please do variants. Okay, you do your paper 4 is on Wednesday. Do 41, 42, 43, right? Because the syllabus is the same, the only difference in the variance is the time zone, right? So go over your variance. It will just help you get more practice in. Students who are doing Edexcel board, you can do both the code for R and the one without R, okay? Because the R is once again only for the time zone, right? That's it. It's just to distinguish between two different time zones. The syllabus is the same, questions are all similar. It's just going to get you as much practice as possible. Students who are still feeling a bit iffy about the theory, go over notes. Okay, go over notes as much as you can, and then practice past papers. Right now is the time that you should be practicing as much past papers as possible. Okay, we have a question: how do we convert mole per dmq to gram per dmq? So to do that, you basically just divide it by the mr. Okay, one second, just give me 1 second. Right, sorry. Okay, yeah, I was talking about conversion. To convert mole per dmq to into gram per dmq, you are going to multiply. I'm sorry, I think I said divide. You're going to multiply it by the mr. That's it. Okay, Al-Jahar, that's all you have to do. So you take the whatever like is given to you, let's say sodium chloride, right? So you want to convert the concentration of mole per dm cube into gram per dm cube, simply multiply it by the mr of or molecular mass of sodium chloride, and you should get the answer. As for resource center, Zainab, you'll have to ask the academy. Okay, it's up to them. I don't know. You'll have to ask them. Um, okay, yes. Catalytic converter, yes, we can go over catalytic converters. So when you talk about your car engines, okay, car engines produce two really bad gases. One is nitrogen oxide and one is carbon monoxide. Nitrogen is generally non-reactive, but it reacts with the oxygen in the high temperature and pressure of the car engines to make nitrogen oxide. And of course, carbon, because there is incomplete combustion happening, so we get carbon monoxide. Nitrogen oxide, like you have said it correctly in the chat, it causes eye irritation, skin issues, it causes photochemical smog, it's bad for breathing in, so it's generally bad for the environment. And nitrogen oxide can react with the water vapor to make acid rain. And carbon monoxide, what does carbon monoxide do? It affects the transport of oxygen in the body. If you inhale it, it reduces the amount of oxygen being transported. So what does a catalytic converter do? A catalytic converter uses a catalyst, okay? And in the presence of catalyst, it reacts so the engine is producing two bad gases, carbon monoxide and nitrogen oxide. So what it does is that it reacts the carbon dioxide with the nitrogen oxide, okay? And it does this in the presence of a catalyst. Normally it's platinum that we use. So you get carbon dioxide and nitrogen gas. Okay, this equation is not balanced, but you guys can balance it out. But basically, it will give you carbon dioxide and nitrogen gas. So carbon dioxide is still bad for the environment. It's a greenhouse gas, but at least it's not going to be toxic to people, right? And nitrogen gas is, of course, inert and found in the uh, environment normally. Okay, all right. Okay, guys, so we'll go ahead. I think we'll stop it over here for today. And right, so that is it for today. I really hope this class was helpful for you guys. A small crash course. I know we couldn't cover all the details, but I really hope it was helpful for everyone. Best of luck for all of your exams. I hope each and every one of you does really well. And yeah, thank you. And yeah, guys, a small reminder before we go, we are starting our A-level classes July onwards, probably June, July onwards. And we have really limited seats because we take really small batches, only 2 to 3 students, 3 students at the most. So we don't have a lot of seats. So we are starting with our A-levels classes. So if you guys are interested, please go ahead and contact the admin. I will share the PPT with you guys. The class recording will also be shared with you, 3 hour session, but do give a bit of time, right? Because they have to upload it and share the link with you guys. It's quite a long recording. So give it a bit of time and they will share all these things with you. And I wish you the best of luck to each and every one of you. I hope you guys do really well in your exams. I'm so glad. Thank you so much, guys. I had a lot of fun teaching you guys. Bye, guys. Bye. Bye from my side. Bye to everyone. Best of luck for your exams.